Hey guys, welcome to parsing the $ MFT, the master file table, particularly the data attribute, the $data or hex 800000 metadata attribute. We're going to look at run lists today. I'm going to show you how to take um, an entry in the master file table and find it on the hard drive in its various fragmented pieces and piece it back together, all using open source or free tools. Okay, and so the tool of choice today is going to be FTK Imager. That's a common open source. It's not really open source. It's freeware. It's provided by Access Data. It's a really powerful tool for free. I'm surprised they still make it for free, but it's a great little tool. So we're going to go ahead and jump in here. I'm going to add an evidence file, which is actually just one of my physical drives on my hard drive. Um, it's one of my data drives. We'll do physical drive 3. It's got some videos on there, which are big files typically. In fact, we'll try to recover manually a file that's not actually lost. It's not deleted. We could go out onto physical drive 3 and look at my partitions under projects, under root. Down here, I've got some video lectures that I've done for CFR 105. And here's if we order them by size, FAT32 file system .mp4. So it's a video. It's 1.3 gigs, a little more than 1.3 gigs in size. Good chance it's going to be fragmented out there on the hard drive. Okay, so that's the file we're going to go. It's even though it's not actually lost, we can take a look at it here. Uh, look at the file signature for it. We can see if we look through the file signature down there, it tells us it's an H.264 encoded MPEG-4 using the AVC codec. So wonderful. We now know that that's what we're looking for. This is the file that we're looking for. When we find it using the master file table, we'll feel good about ourselves. All right. Some of the prep work that I've done for this is that I've created just this text file over here on Notepad, and basically I went ahead and put down some notes for me to copy and paste some information from FTK Imager over here, and then maybe have to do some calculations using a calculator in a little bit. But when when the master file table writes a file out to disk, it will use up this chunk of space, and then it'll jump to this chunk, and sometimes it'll look back to the beginning of the drive and go, oh, there's some open space back here. We got to write a chunk of the file here, so they can be all over the place. So we're going to take a look at how to, again, organize our thoughts with all of this information that the master file table gives us. That's why I've got the Notepad open. And so if you're following along, if you're trying this, I really recommend having Notepad open, having your first run list, your second run list, your third run list, your fourth, fifth, sixth, however many run lists there are. We're going to start with 4. That should get us through this. It could be less, it could be more. Okay, the master file table is going to tell us 2 things about each run list. Or each fragment. It's going to tell us how many clusters it is total and where it starts. And so those are the 2 pieces of information that it's going to tell us. And then we're going to have to do some conversion from clusters to bytes, because FTK Imager, when we select big chunks of data, it wants to do it in bytes, not in clusters, which is fine. That's an easy calculation. Okay, so we're in the root directory of the my hard drive, right? My physical drive 3. I call it projects NTFS. If I highlight the root directory in FTK Imager, you can see all of the main files in that directory, in the root directory. Many of them are the $ metadata attribute files of the NTFS file system. The one that we are, of course, interested in is the MFT. It's also the biggest one there. Just a quick review, the MFT is a catalog of all files in the file system, including itself. This first entry here, we can see, is in fact the $MFT. So that's good. That's good. We're in the right place. But what we want to do is we want to look for using the file name attribute, which we've discussed previously. In fact, this is the file name attribute right there, right? Starting if I'm reading the matrix correctly, right there, 300000. That's the header for the file name attribute. It is 8 hex uh, bytes long. So we're going to go, let's see, there's 8, then there's 1, 2, 3, 4, 5, 6. So that's the entire file name attribute. Anyway, we're going to use that file name attribute for the FAT32 video lecture that I did. And we're going to just go find it. So it's really easy. We're just going to right click over here and we're going to go find. And we're going to do text. And we're going to look for FAT32. And I don't remember what the rest of the file was called, so we'll just take our chances and see what it finds. Well, there's FAT32 library jar. That's not what we want, so we'll hit F3 to find the next FAT32 entry. It'll search for us. And there's another one. Let's see, FAT32 file system. Oh, PowerPoint. Nope, we don't want the PowerPoint, so we'll hit F3 again. And there we go. FAT32 file system MP4. Perfect. And let's see. We're still in the master file table. Okay, that's good. Let's see. Here's the first 56 bytes right there. Okay, and then there's the standard information attribute for six rows. And then there's the file name attribute for 8.5 rows. To here, and then here's the data attribute. Okay, this dollar sign, it's $ data, but recognized as hex 800000. We know that it's going to go for 6 lines or hex 60 bytes, so we're going to just go 1, 2, 3, 4, 5, 6. That's our entire data attribute. Okay, so all of our run lists are included in this block here. And that's great. And so we also know here by this little flag that our first run list starts 4 rows down from the beginning of the data attribute. So there's 1, 2, 3, 4. So here is our first run list, starting with hex 43. Now, the first byte of a run list is a flag itself. It tells us the total number of bytes in the run list. So there's 7, right? 4 and 3. It tells us that the first 3 bytes are the size of the fragment or the run list, and the next 4 bytes are its starting location in clusters out on the disk. All right, so this is where we just start copying and pasting some information here. This is our, I'm going to get on my old man glasses here now that we're getting into the numbers. Right here, read in little endian, if we were to convert that using a calculator, it would give us this value up here, 323 million, blah, blah, blah. That is our starting cluster for this first run list. So we'll just double click that, right click copy, and we'll put it right over here, starting cluster, control V, signed integer, and I'll tell you what a signed integer is in a minute. So there's our starting cluster, and here's our length in clusters. Again, 016D D0 calculated to decimal is 93,648. We'll copy that. We'll put that up here. This is in clusters. We're going to have to convert that to bytes. Okay? All right. Let's go do our next run list. So we know this one was 7 bytes long, right there. 1, 2, 3, 4, 5, 6, 7. The next run list is right here. There's our flag for the next run list telling us that there are 6 bytes in this run list. The first 2 are the total length of that fragment. So we'll go ahead and double click that. 16,754 clusters in length. Okay. And we know that it is FF6FEF9. 5 bytes represents the number of clusters where it starts. But wait a minute. Our hex calculator here has told us that this is either 4,285,525,909 clusters into the disk, or it has a packed byte there in this particular sequence, um, there's a byte or a nibble that tells us that this could potentially represent a negative number. And um, in NTFS, in the master file table, if it could be a negative number, that's not by accident. They flagged it as a negative number on purpose, which means this next fragment starts 9 million clusters from the beginning of the last fragment. Okay, so we're going to have to do a little bit more calculations, which we were going to have to do anyway, because each fragment, each run list doesn't give us the starting location or the starting cluster from the beginning of the drive, right? It doesn't give us from cluster 0. It gives us from the starting cluster of the previous fragment, okay, or the previous run list. So we're gonna have to figure that out. Not rocket science, we can do it. Okay, he said, hopefully on video, hoping not to look like an idiot in front of everybody. Okay, so there we go. We're going to take this negative number, we're going to copy it, and we're going to put our starting cluster right there. Signed integer negative 9,441,387. All right, our next run list has a header of 32, or 32, not 32, hex 32, which tells us that it is 5 bytes long. So the next 5 bytes will be relevant and pertinent to us. There they are. And the first 2 bytes are what? You tell me. Those are the number of clusters that fragment occupies. So we'll copy that and we'll put that up there, length in clusters, Control V. And then the next 3, okay, it's going to be our starting cluster from the previous cluster. So we're actually gonna let's go ahead and copy that out there. Copy and starting cluster, Control V. There you go. So we're gonna take this first starting cluster, 323 million something, and we're gonna go get that fragment. We're gonna copy it out, and then we're gonna go back 9 million clusters, and we're gonna take the from that starting cluster. We're going to take the next 16,000 clusters. And then we're going to from the number that we get by subtracting 9 million from 323 million, and we'll get that in a second. Then we're going to add 5,602,988 clusters to that, and then take the next 17,000 clusters. You see how this is going? Okay, let's get this last one. We have one more run list here. It's the header for the last run list is 33. So I said it again. It's 33, hex 33, not 33. When you speak decimal from the time you're 5 years old, it's really hard to break that habit of saying 33 when you look at the digits 33. Okay. All right. So the next 3 digits or bytes are going to represent the total length in clusters for this last data run. So we're going to come up here. We're going to take this value, copy it, length in clusters, Control V, there it is, 210,000. And then the last 3 bytes represent, another signed integer. All right, so it's going backwards again, this many clusters from the last cluster. All right, well, let's see if this makes sense. First of all, we need to convert clusters to bytes, right? Because when we go looking for it in FTK Imager, it's going to ask for the number of bytes to select, right? So if we've got 93,648 clusters, well, we need to know this volume. So we need to know some things about this volume, like the cluster size. Aha! There you go. So it's 4,096 bytes per cluster. Okay, I'm assuming that those are 512 byte sectors and that there's 8 of them in the cluster. That doesn't really matter. We just need to know that there's 4,096 bytes per cluster, because now when we go up here and we start to do our math, right, where's my calculator? Here we go. All right, so if we're up here doing some math, we're going to say 93,648 times 4096. Bam. And there's our actual length in bytes. That's useful. Okay, so we're going to right click and copy, and we're going to just put that out there next to this. Okay, maybe I'll put on the next line. Okay, And we'll do that for the next one. Let's clear this, and we'll say 16,754 times 4096 gives us 68 million and something. So we're going to paste that right down here under this one. Okay. Total length of that fragment in bytes. We'll do the same thing for this one. 17,071 times 4096. And copy and paste. We'll put it right under there so we know that's our length. And one more. We got to do one more. This is fun. Isn't this super fun? You never thought forensics could be so fun. 210,997 times 4096 gives us 864 million bytes for this last. So videos are big, right? This is, what was it? I don't remember how long that FAT32 lecture was in minutes. I think it was like a half hour or 45 minutes or something. Maybe it was longer, maybe it was an hour, I don't know. But it was long, and that's a lot of bytes, right? It's 1.3 gigabytes. So there you go. All right, so those are, if we add all of these up, by the way, that should give us the total file size, right? It should give us 1.3 gigabytes. I'm not going to do that. Let's take a chance. I mean, you could do some air checking right now and see if we're on the right track. But the last thing, let's see, the last thing we need to do is we need to find the starting cluster here for the second run by subtracting 9441387 from 323 million. So let's do that. Let's go 323,206 928 minus 9441387. And we'll just copy that. That's our actual starting cluster for the second fragment. Okay, that's nice. That's handy. All right. And then we need to do that. Let's see, we need to add 5 million to this number. So we're going to, so plus 5,602,988. And there's our next starting cluster for our next run list, our third fragment. Okay, and now we need to take away 1.5 million from that, minus 1540396. So that's we're going backwards again on the hard drive to this cluster. Copy it and paste it. All right, clear as mud. Hopefully you're following, you're tracking me. Okay, we'll put the calculator away right now. So now we're going to go back to the beginning of the volume, right? So before we were in the root directory and we were poking around in the master file table down here, right? Now we're going to go up to the volume, right? Because these clusters are actually logical cluster numbers from the beginning of the volume. All right, so let's go to that first cluster. We're going to right click down here. We're going to say go to sector or cluster. We've got cluster, we've got decimal selected. Our starting cluster is this number here, so I'm just going to copy that and paste it right into here. Now with this first one, it's got commas in it. FTK Imager doesn't like commas. We're going to take the commas out, and we're going to go find the video out there on cluster 323 million. All right, are we there? There we are. Let's see. See, now it's butted right up against another sector, some other file ending right there. Here's the beginning of our video file. That's the first cluster. Does it look like it? F-type ISOM ISO2 AVC. Yep. H.264 MPEG-4 AVC codec. Yeah, all right. So we did find the first cluster. Yay, us. Good for us. Now we're going to right-click and we're going to we want to set selection length, okay, in bytes. That's why we had to convert this cluster. This gave us the length in clusters. The master file table gave us the length in clusters. We multiplied that times 4096, gave us this integer right here. So we're just going to copy and paste that right into here. Control V, shabam, and okay, there we go. Now, we've got all those 383 million bytes selected. We're just going to right click and save selection. I've got a file folder saved out here for fragments. Um, on my desktop, I made a little little directory here, and I'm just gonna call it fragment one. Good grief, if I could type fragment one. And I'm not gonna put a file extension because it's just a fragment. It's just raw data. Bam. Let's take a look out there and see. There it is. Okay, it's there. That's good. If you wanted to do a CLI here, directory, yep, there it is, fragment one. Okay, good. We're looking good here. We're looking good. All right, so from here, we need to go to the next run list, the second cluster, and we are going to go to starting cluster here. Uh, 313 million. Copy and right click and go to sector cluster and paste it in there and go. All right. Oh, that's a good sign. I always like it when my file fragment is right at the there's nothing behind it. I can tell that this is a continuation of another file. So good. So now we need to right click and say go to set selection length. What's our selection length for the second run list? Right here, we converted it to bytes. Control C over here, pasting it in here. Control V and OK. Now I've got those 686, no, what is it? Uh, 68 million bytes selected. Right click and um, save selection. Save selection. There it is. And we'll call it fragment 2. All right. Woo! See how we're doing here. Make sure it went out there. There it is, fragment 2. Good. CLI. There they are, 2 fragments. One's 383 million bytes and the other one's 68 million bytes. We're looking good. Okay. Back to FTK Imager. The third run list starts at cluster 319 something. Copy that. Right click on FTK Imager. Go to sector cluster. Paste it in there. And okay. So I know this is kind of tedious. Now we just have to do the work. Okay, so again, now I always get a little nervous. Oh, but that's okay. These are clearly um, two different files. That you can see the difference between the sector above and where the sector we're starting is. This looks more like almost like a file allocation table, right? But we know it's not. But it is some kind of an index, right? You can tell by the regulated things there. This is some kind of an index file. All right. So we're just going to say take that first byte, and we are going to say how long is it? It's this long. Control C, right click. Let's see. Right click, selection length. Control V, and there we go. How many are selected? A lot. Okay. Right click and save selection. Fragment 3 and save. Okay, I'm confident that we got fragment 3. I don't think we need to check. What the heck, let's check. There it is, fragment 3 is there. Okay, fourth run list. We're almost done here, guys. We're going to take our starting cluster right here. Control C, right click, go to sector cluster. Woo, and go. All right, there we are. Whoops, I lost my place. I lost my life. Where is it? Is this the starting cluster or is it up here? Starting sector. There it is. Okay. Whew. Okay, starting sector. Again, it looks like 2 very different files, so I can be confident that this is, in fact, we're in the right cluster. That's pretty good. I'm going to right click now and go to select selection length, which is right here. Control C, Control V, and bam. Now I've got all those clusters selected. Right click, save selection, fragment 4. And save. All right, now I've got all 4 clusters saved in my little directory I made there. That should be the whole. Uh-oh. Oh, there it is. Whew. It said 0. Scared me. All right. So, again, if we add all these up, it should add up to 1.3 gigabytes. I think we're looking good there. That looks about right. 374 plus 67 is going to be, what is that? 4. Let's say 4.3 plus another, let's see, 3.7 plus, let's say 7, that's going to be 4.4 plus 7 is 2, 4.1 plus 8.3 puts us right there at 1.3. We're looking good. All right, so just a quick little head check there. All right, so now we're going to go into our command line prompt, our command prompt, and we are going to just simply copy all of the we're in the right directory. If you're not in the right directory, you have to get to the right directory. So I went ahead and did my little change directory and got here. We can do a dir, make sure they're all there. Okay, all 4 fragments are there. And then we're going to do copy, and then we're going to do a batch command, B. We want everything in there, so we're going to use our little wildcard asterisk. And then we're just going to name the file that we want to call it. And we're going to call it, what do we want to call it? Fragments, all fragments .mp4. Now we want to give it a file extension name because we want it to be encoded we want Windows to see that. And cross your fingers. Okay, it says it's there, dir, and all fragments mp4. Let's try to play it. Moment of truth. All fragments .mp4. Here it is.
All right, guys, welcome
Holy
to
Hannah,
week
we did
3
it. There I am.
Of file system forensics.
You
This
have
week we're going
successfully
to dig
now
into our first
collected
actual
4
file
fragments
system. We're going to
using
look at
the
the
run
FAT32
lists
file system
with the. All right, that's enough of
and
that.
some of the
Be quiet. All right. Using the run list, you've identified starting clusters and cluster lengths. You've copied those out using FTK Imager, put them in another directory where you could go and find them later, and then we use the Windows command line to concatenate those files into one file, and it worked. We have manually carved a video from various places using signed integers to go backwards from cluster to cluster to cluster. All right, and forwards, signed and unsigned integers. That's all. Oh, yeah, sorry. I guess I didn't realize that my face was over here on this. Sorry about that. If you need to take a look over here at the command line stuff that we did here, particularly this little uh, command right here, copy /b asterisk, and then name your file all fragments. Now, what's important is that you are operating in the directory with all those files. You wouldn't want any other files in there because when you do the asterisk here, it grabs every file in that directory, and you don't want to. It would be like Jeff Goldblum in The Fly, right? If you're mixing all these files together, if you have another file in there that doesn't belong in there, it's going to be this hideous, deformed thing. It's not going to work. It's probably going to die or be corrupted, or it's certainly not forensically sound if you're actually trying to recover an evidentiary file. All right, that's all I've got for you. I hope it was useful. I hope you got something good out of this. We can be proud of this. We can be proud of this. This is good forensics right here.
All right, guys, welcome to.
All right, there's that. You've done it. I think that's all I've got for you. Hope that was helpful. Good luck on the assignment.